Thank you, Greg. And thank you for all of you that are still out there. What an inspiration those two videos provided. Too wide seeing at its best. There's a lot of sharing that still needs to be done, and I hope to be part of that. And so I'm speaking with respect and humility, and I'm going to present some information on fish in Lake Huron. My passion is fish, so thank you for the invitation, and hopefully I can convey to you some insights into what's happening with fish communities on Lake Huron over the last couple of decades. I've been around for over 3 decades, so I'm just going to provide snapshots of what's going on with the fish communities in the lake. It's not going to be totally comprehensive, but it'll give you a sense of what's going on. And I just wanted to acknowledge all the contributors of information to this presentation: government agency, tribal communities, First Nation communities, and others, NGOs. They've all contributed information to this presentation. So without further ado, let's talk fish. So I thought I'd start with a mood shot. This is part of the biosphere, French River Delta. It's beautiful, but it also has ominous undertones. So there's a lot of beauty in the biosphere and Lake Huron in general, but there's a lot of change that's going on that isn't necessarily beautiful. So I'm going to try to highlight some of the concerns that we've been observing over the last little while. And I'm going to summarize the major themes of my presentation in this slide. And take them as take-home points. So in terms of the fish communities in Lake Huron, they are very distinct by basin and by region. Sea lamprey. Many of you have probably heard about sea lamprey for quite some time now, but sea lamprey are a major factor on the dynamics of fish communities in the lake, and I will show you some information about that. There's been incredible change in the lower food web of Lake Huron. Probably the most profound and pronounced changes of all the Great Lakes are occurring in Lake Huron. The pelagic fish, those fish that live offshore, the prey fish that provide sustenance for the larger bodied fish, the predators, have declined dramatically in offshore waters of Lake Huron. Lake whitefish, culturally, economically, sociologically, a very important fish species, is in rapid decline in Lake Huron. Lake trout, the keystone predator in the lake, is undergoing some level of recovery, primarily in the main basin, but not as much in other parts of the lake, with the exception of Parry Sound. Walleye. Walleye have experienced an incredible resurgence in parts of the lake, particularly Saginaw Bay, much less so throughout the rest of the lake, with an exception being the Shawanaga River area. And I'm going to end the talk with just highlighting some of the unique characteristics of the nearshore fish community and how, in general, it's remained more resilient than the offshore fish communities in the lake. So let's start out with sea lamprey. And I know I've got about 30 minutes of speaking time. I could probably spend a day filling you in with facts and factoids about sea lamprey, but I don't have a day. So I'm just going to give you the highlights. So sea lamprey are an invasive species that were introduced into the Great Lakes back in the 30s and 40s. And it's just a classic example of how some introduced invasive species can have long-lasting impacts on fish communities. So sea lamprey are still a major driver of fish community dynamics, particularly for offshore communities. The graph there shows the abundance of adult sea lamprey over time from the 1980s to more recent years. And that downward trend is a result of sea lamprey control that comprises a huge program that occurs on an annual basis. And the Great Lakes Fishery Commission and Sea Lamprey Control have a target level of sea lamprey abundance, about 38,000 adults. And that was reached a few years ago with a fair bit of fanfare. There's a lot that goes into controlling sea lamprey. But you can see in the last few years, the trend has been going up. And unfortunately, that's the dreaded COVID effect. So COVID basically created a situation where sea lamprey control efforts could not take place like they normally would. So for 2020 and 21, the sea lamprey control technical teams could not go out and perform the control measures that they do annually. So in just a few years, you see that increase in sea lamprey abundance. So sea lamprey control is something that we're basically embarking on for the long term. Sea lamprey control is comprised by applying a lampricide to river systems, as well as producing barriers to the upstream movement of adult sea lamprey. This is just an example of one of those structures, the Nicholson Dam on the Nottawasaga River. The problem with these barriers is they don't let native species reach their natal spawning locations. The fishways that are associated with these barriers are primarily for introduced non-native salmonid species, like salmon, rainbow trout, that can jump, whereas suckers and walleye and bass, they don't have that same jumping capability. So these barriers basically block off river systems to a lot of native fish. So it's an area of research that is ongoing. I'm going to talk a bit about the disruptive qualities of invasive species, and it's going to be a recurring theme, invasive species. Many of them arrived through the transport of goods and services through the St. Lawrence Seaway. The first wave was sea lamprey, alewife, and rainbow smelt in the 30s and 40s. The second wave is more recent, and that's the introduction of Dreissenid mussels, the zebra and quagga, the round goby, and the spiny water flea. These are the more pernicious culprits, as I'd like to describe them as. So these organisms, not native to the Great Lakes, have disrupted the ecology of all the Great Lakes, especially fish community dynamics. So I'm just going to touch upon some of their impacts. This slide shows the major changes in benthic organisms. So the base of the food chain, what juvenile and small fish feed on. And on the left-hand side, you could see the proliferation of quagga mussels, these introduced mussels into the Great Lakes. By 2017, they exist throughout the deep waters of the lake. They occupy the bottom, and they're filter feeders. So they basically sequester all the nutrients in the water column. Many people don't realize that quagga mussels have now replaced zebra mussels as the primary filter feeder in the lake. Quagga mussels occupy very deep depths, and so they're doing a more effective job of reducing nutrients in the water column and locking those nutrients up. So not many fish can feed on quagga mussels. There are a few exceptions. So a lot of the nutrients that used to be in the water column are now locked at the bottom of the lake. And on the right is Dipraia. It's a little amphipod that historically was a very important fish food. And they are basically disappearing from the bottom of the lake. And it's a result of these quagga mussels displacing them. Still trying to figure out the mechanism for that, but a food source rich in protein, that being the Dipraia, is now being replaced by Dreissenid mussels that have a much lower caloric and nutrient content. So fish diets are being compromised by the loss of that benthic organism, the diparia. And what the result of that is that the prey fish that used to occupy the offshore waters have been reduced to very low levels of abundance because there's no food for them to feed on. And this graph shows the reduction of prey fish in the offshore waters of Lake Huron over time. And at the early portion of this graph, the green and yellow represent the alewife and rainbow smelt, the non-native prey that were introduced into the lake. Those prey items basically supported a very popular recreational or artificial fishery that supported Chinook salmon, coho salmon. The reason why the Great Lakes were stocked with these predator species that are native to the Pacific coast was to control the numbers of alewife and rainbow smelt. The reason why alewife and rainbow smelt were so abundant was because the keystone predator, lake trout, were decimated by sea lamprey. So you're seeing all these linkages and connections. So alewife and rainbow smelt collapsed in Lake Huron in 2004. Most people aren't aware of that. Well, what happened? Well, we kind of had all the key ingredients to the perfect storm. So the Dreissenid mussels, coaga mussels expanded, a lot less nutrients in the water column, less phytoplankton, less zooplankton, less feed for fish. Alewife had no food to feed on. We had a relatively severe winter in 2003 and 4, which resulted in almost the entire die-off of alewife year class in 2003 and 4. So there's been a huge shift in the ecology of the lake because of the collapse of alewife brought on by less nutrients in the water column because of zebra mussels. Alewife, again, not native to the Great Lakes, but became very abundant and basically collapsed in 2004. So there's pockets of alewife. There's still alewife in Parry Sound and a few other embayments, but their abundance is much less than they were 20, 30 years ago. So therefore, there's much less predator biomass that can be produced because there's less feed to feed on. So this is just an example of some survey data from the U.S. Geological Survey that does trawling and acoustic work to look at the prey fish population in the lake. And you can see that there's only a few concentrations of alewife in the main basin, the northwestern portion in the main basin. And when you look elsewhere, there's very little density of alewife. Rainbow smelt, again, another species that was non-native to the Great Lakes that supported predator populations from the 60s through to the early 2000s. And you can see that their numbers have collapsed dramatically as well. And that's, again, linked to the reduced lower food web productivity. They're still found in the southern main basin, North Channel in particular. North Channel has fewer Dreissenid mussels and therefore supports a bit more prey density. But again, these densities are much lower than they were 20 to 30 years ago. I'm going to mention the bloater. I have a talk that's several hours long about the deep water Cisco species flock that most people don't know about. But if you're into fish, that deep water Cisco species flock is very interesting because historically, the offshore waters of Lake Huron and the other Great Lakes supported these Cisco, deep water Ciscos. They ranged in different sizes. They had different lipid contents, so they occupied different depths of the lake. So the offshore waters of Huron and the other Great Lakes were much more productive than they are now. We basically lost that Cisco species flock because of the changes in the ecology of the lake. So there's one species left, the bloater chub, and it's now actually the most abundant prey fish in offshore waters. The thing is, it's not utilized by species like Chinook salmon, coho salmon, because it's deep and it stays near the bottom. And So the one positive thing is its abundance is increasing in recent years, and it's a native species. So we're getting more native species representation in prey fish. However, the overall density and biomass of prey fish is still quite low compared to what it was historically. And this is just an indication of its distribution. So it's found throughout the main basin, in Georgian Bay and the North Channel. So there is still some hope for the native prey fish in the lake with the representation of bloater. So deepwater cisco are different than cisco, okay? Cisco, otherwise known as lake herring, is a relatively shallow form of prey fish. It's distributed throughout the lake, used to be found in very high abundance in Saginaw Bay. It actually was the primary commercial fish species targeted in the 1930s and 40s. So it was very abundant. The map on the lower right shows the current distribution of cisco, and you can see that it's no longer present in Saginaw Bay, which is in Michigan waters on the left-hand side there. And so with the collapse of Alewife in 2004, fish researchers and managers and assessment folks thought that there was an opportunity for trying to reestablish this native prey fish in Saginaw Bay. So, since 2015, Michigan DNR, Department of Natural Resources, has been taking wild egg collections of cisco from the northern part of the main basin and rearing these eggs in a hatchery to stock back into Saginaw Bay. So this is probably one of the largest ecological reconstruction efforts on the Great Lakes currently, trying to reestablish cisco in Saginaw Bay. And so far, you know, they've stocked over 5 million fish over the last 5 years, and they're starting to see cisco appearing in Saginaw Bay. And in fact, they're seeing some wild produced cisco. So it's possible to try to restore native prey fish into the Great Lakes, but it takes time and a lot of effort. So that's a brief snapshot of the cisco picture. Let's talk about the ugly round goby. So round goby, part of this second wave of invasive species. We don't really know how abundant it is because it's very cryptic. It tends to hide in hard substrates, in crevices, and it's really hard to try to estimate its abundance with traditional fisheries assessment techniques. We're going high tech with goby research. We're using the goby bot. So this is an autonomous underwater vehicle that you can program transects and let it go into the lake, and it'll just do transects throughout the bottom of the lake, different depths. It has high resolution video and still picture capacity. So it takes pictures of the lake bottom, and it can translate these images and translate that information into enumerating gobies. So that's just an example on the bottom right of what it can do to try to get an estimate, a lake-wide estimate of goby abundance. So this is still in its early stages of development. A lot of transects have been already run in Lake Huron, and preliminary estimates will be pending in the next year or so. But just to give you a brief glimpse of how abundant goby are, we did some recent assessment work in Owen Sound Bay, using a device that was a deep water electrofisher. You can see it on the top right there. You basically lower that mechanism into the water column, let it sit on the bottom. Once things settle, you put electrical current through it, and the goby are stunned temporarily, and you can take a picture and find out how many goby there are. And so we did this in Owen Sound and found, if you look at the bottom left, the density of goby are pretty high from 0 to 30 meters in depth, so about 0 to 100 feet, and then you get a bit of a dip. But then you've got goby that are occupying depths up to 300 feet or 100 meters. So they cover a large area of the bottom. And when we estimate just how many fish that represents, how about 118 million goby, or 144 tons of goby estimated just in Owen Sound Bay. So you don't have to be a fisheries biologist to realize that's a big number. So goby are a major prey item for a lot of species now, and we're still seeing their dynamics evolve over time. How am I doing for time? I have no idea. Do I have 5 minutes left? 10 minutes?
Let's say 15.
Oh, 15 minutes, that's awesome. Okay, let's briefly talk about lake trout. So lake trout basically were almost exterminated from Lake Huron because of sea lamprey. So by the mid-1940s, most lake trout populations were decimated in the lake. That genetic legacy was lost. Keystone predator, lost. Superior maintained a lot of its diversity of lake trout forms. However, in the lower Great Lakes, including Lake Huron, we basically lost that genetic legacy that extends back to the last glaciation. So there are only two populations that survived in Lake Huron, native populations of lake trout, Parry Sound and Iroquois Bay. So I'll mention that briefly. So since the 50s, multiple agencies have been trying to restore this keystone predator through stocking efforts, using strains from Lake Superior, from some inland lakes, trying to restore this keystone predator. And with very little success, up until recently. Why recently? Well, with the collapse of alewife, which was the major prey item for predators like lake trout, Chinook salmon, coho salmon, when they collapsed in 2004, alewife wasn't a major diet item, so lake trout had to eat other fish like goby, rainbow smelt, and other organisms. So when they changed their diet from, I'm going to depict it this way, from junk food alewife to different types of prey fish like smelt and goby, which also can be considered junk food. However, those species don't have something that's very critical, and that's thymidase. Alewife have this enzyme in their gut, which is called thymidase. And for whatever reason, it has a high concentration of this enzyme. If you have a diet rich in alewife and you're a lake trout, you're not going to produce eggs that are viable. So this thymidase breaks down vitamin B, which is an essential nutrient in developing eggs. So when you're eating alewife and you're trying to reproduce, your offspring are malformed or they don't hatch at all. So when lake trout shifted from alewife to these other diet items, all of a sudden that thymidase wasn't as much of an issue and lake trout were starting to naturally reproduce. And that's what you see in this graph. In the main basin, since the collapse in 2004 of alewife, you see the natural reproduction, which is in the red and purple. So we're seeing an increased amount of natural reproduction occurring in the main basin of Lake Huron, something that we hadn't seen in over 50 years of rehabilitative stocking. So like I could go on and on about that. But let's just say it's been a major breakthrough. The one drawback has been that because of the offshore waters are less productive, lake trout aren't growing as quickly. So their condition factor isn't as high. The graph on the bottom just shows that at a certain length, lake trout are not as heavy as they used to be because there's just not a lot of prey fish out there. I thought I'd better highlight Parry Sound. It's a lake trout rehab success story, one of the few outside of Lake Superior in the Great Lakes. We've been monitoring lake trout in Parry Sound for a while now. The last survey was 2016. It's amazing how time flies. But basically, when we did our monitoring of that population, we showed a diversity of year classes. All these fish are wild, they're unclipped, they're not stocked. So lake trout are naturally reproducing in Parry Sound, and they're growing to a ripe old age. So we're getting some fish over 20 years of age. So it's a healthy lake trout population. Lake whitefish, oh my goodness, just 15 minutes, eh? Wow, okay. So lake, 10 now, okay. Lake whitefish. So I don't want to give short shrift to whitefish, but it's a very important fish species, culturally, food security, and it's going down. It's going down rapidly. The graph on the bottom right shows Southern Georgian Bay, our index monitoring site, and you can see that since 2005 or thereabouts, there's hardly any sign of lake whitefish. Hardly any reproduction of lake whitefish. And again, it's part of this invasive species issue. Are they not reproducing? Are the adults not fit? Is there no food for the larval whitefish when they hatch? Those are all research questions that are being investigated. We've done some trawling on the west side of the Saugeen Peninsula to try to find out whether whitefish eggs are actually hatching and whether larvae are being produced. They are. However, the amount of larvae being produced in recent years is much lower than it was historically. We've got a time series from the 1970s through the 1980s, and we've got some more recent data, and we basically are showing that there's very few larvae hatching where they were historically. The ones that do hatch are also growing much slower than they were historically. So the growth rate has declined, and the research question here is it because there's no zooplankton for them to feed on? That seems to be the case. So the plight of whitefish has resulted in an incredible partnership between Saugeen Ojibwe Nation, MNRF, and Parks Canada, together with Giguyag. It's a collaborative research endeavor which is using two-eyed seeing and is using an incredible acoustic array, a sonic acoustic array that's being set up in the lake, trying to monitor the movements of adult lake whitefish, finding out where are they spawning, where are they feeding. So basically, Lake Huron is now wired for sound. So these are the locations of acoustic receivers that can monitor the movements of tagged lake whitefish and lake trout and walleye and other species. So you put a tag, a sonic tag into these fish as they move. These receivers receive a signal. So you can document where these fish are moving over time and get a much more clearer picture of fish movements in the lake. I'm going to end the whitefish story by saying we have so dramatically altered the ecology of the lake that when you look at whitefish diets now, it's primarily non-native invasive species. So round goby, Dreissenid mussels, bithotrephes, rainbow smelt. The only native organism is the clams, or the shells, the clams, I should say, mollusca. So we've really done a number on changing the ecology of the lake. So do I have 5 minutes left at least? Okay, incredible resurgence, again, connected to alewife. Alewife adults consume larval yellow perch and walleye very effectively. So they were basically eating all the year classes that were being produced in Saginaw Bay. When they collapsed in 2004, all of a sudden walleye were reproducing and producing consistently strong year classes. So estimates in Saginaw Bay are over 10 million adult fish currently. We're not seeing that in the rest of the lake, especially Georgian Bay and the North Channel, because the populations here are associated with shield river systems, less productivity, and they're smaller and more vulnerable to exploitation. Most of our walleye populations that we monitored have high mortality rates and low abundance. So when you're trying to rehabilitate a species like walleye, it's very difficult to do that in the midst of constant extraction of the resource. And walleye are very much sought after by recreational fishers and other fishers as well. And they're a challenge to monitor. This is just an indication of sampling areas that we've established within the lake. So we've got close to 30 populations of walleye that we can monitor in Ontario waters, and it's been a challenge. And I'm glad I focused on the Shawanaga River population. We've been monitoring that in collaboration with Shawanaga First Nation, and it's one of the few populations that's doing well in eastern Georgian Bay and the North Channel. It's a critical source population. The one map shows the distribution of tagged fish after they've been tagged during their spawning event. You can see that those fish disperse quite a ways. You find them in Parry Sound, you find them in Magnetawan River area. So that population provides fish for adjacent areas. So it's very critical in terms of walleye protection and preservation. I would be remiss if I didn't mention muskie, my favorite fish. So we monitor muskie populations. It's a difficult species to monitor because it's not found in high abundance. The adults are difficult to capture in our traditional capture gear, but we have been doing live capture trapping of muskellunge throughout eastern Georgian Bay and the North Channel. We've done some netting in the Shawanaga River area, and they're still present. There's less than a handful of locations in the Great Lakes where muskellunge are reproducing and self-sustaining. And Georgian Bay and the North Channel is one of those areas. And the only reason why they're there is because the wetlands are still intact. They haven't been developed and diminished because of landscape alteration. So I'm going to finish my talk, 3 minutes, to talk about nearshore fish species and how difficult it is to answer the question, well, how are the nearshore fish species doing? Well, it depends on where you are and what type of survey results you're looking at. So I'm going to use Shawanaga as an example. Shawanaga. This is one of our sampling areas, our nearshore assessment zone for Shawanaga. Those are netting locations from 3 different survey types. What does that tell us? How do I convey that to the general public? What is happening? Well, I'm going to do this very quickly. This is going to be a shotgun approach. I'm just going to highlight the major elements of the fish community in the nearshore for Shawanaga, using trap nets in the spring. Smallmouth bass, major species in terms of numerical abundance. These 5 species of fish, smallmouth, brown bullhead, walleye, rock bass, and red horse sucker, represent about 86% of the fish that we see in our trap nets. So a majority of the fish, represented by 18 species in total. How about by weight? Weight, the biomass of fish that are produced in the lake, probably more important than the number. These are the highest represented species in our survey netting using trap nets. Smallmouth bass, it's the major biomass representative in the nearshore fish community. And its numbers are probably going to grow over the next few years because climate change, global warming favors this warm, cool water fish. Suckers are abundant. Walleye. You're going to notice that walleye represent a pretty good proportion of the biomass in this area of Georgian Bay. You don't see that in other parts of Georgian Bay. So it's an exception, and it's a good sign that things are pretty good, pretty balanced. Northern pike also come out here, and that represents about 80% of the biomass. And then there's variation from year to year. So 2015, 2016, basically pretty consistent results with bass important, walleye important, northern pike important. Okay, I'll mention those red horse suckers as well. They're important as well. So that's kind of in the spring. If we look at numbers, biomass in the summer using graded mesh gill nets, this is where you see other fish species like yellow perch turning up. They don't get caught in our trap nets because they're too small. But when you use small mesh gill nets, you see that perch are still pretty prominent. They just don't grow to a large size for whatever reasons in Georgian Bay. But again, the take-home message here is that walleye are still represented in this survey as being a prominent part of the fish community in terms of biomass. And you don't see that in very many locations. We also have a fall walleye index netting program. Again, yellow perch prominent, but walleye are still there. And bass, northern pike. So those are the major fish species that we see. So that's the species mix in Shawanaga. I could go to other parts of the bay and tell you a whole different story. But apparently I don't have time for that. So I'm just going to have to leave it at that. That nearshore fish communities are still diverse and dynamic, still holding up, but the offshore fish communities have been dramatically altered. So as the Shawanaga River flows, so does our pursuit of knowledge and insight into fish communities. So thank you for your attention. That's all I have.
At the risk of allowing more time for Ernest, we are going to take some questions, Ernest. Ernest, do you want to take? I know. Yeah, don't. We could have just said go and read the fish chapter, couldn't we? No. Well, that's the wrong one. Sean.
I was just wondering, we have freshwater jellyfish in Georgian Bay. Is there any kind of study being done on that? And what food source are they taking?
Jellyfish isn't a fish. Is that a trick question? Yeah, I've heard or I've seen reports of those jellyfish. I really don't know what the implications of that are in terms of the ecology of the lake. But it's just one of those signs that, oh, this is different. Is it a result of warming trends? Result of changing representation of fish species or the lower food web? I can't really answer that adequately, sorry.
What is anything eating the zebra and quagga mussels, fish species-wise? Other round goby?
The round goby are eating them. Lake whitefish are eating them. You'd be surprised that sunfish eat them as well. Rock bass eat them, but not nearly enough to control their numbers.
Cormorants?
No, I don't believe cormorants, but they eat round goby, yes. No, there's
Man.
If one wanted to eat local fish, what fish should we eat?
in moderation. You name it, like bass. Bass are a good eating fish, and from Georgian Bay in the North Channel, bass aren't infested with a lot of parasites as they are in some of these smaller inland lakes. So bass are, of course, walleye, but I don't want to encourage too much walleye harvest. Northern pike, like really, a lot of the fish out there are great to eat. But check your contaminant guide to make sure that you eat appropriately sized fish, because some of them do have higher levels of mercury than you really want to consume too much of. That's it.
All right.
Excellent.
Yeah.
Oh, thank you.
Thank you for the right name this time. Yeah. All right. Thank you, Ernest.